Welcome to part 1 of the first of our grade 10 and 11 trig theory revision videos. These first couple of videos will cover essential knowledge for success in trig, starting first with the definitions of the ratios and then looking at the 180-360 degree rule. We do encourage that you take notes along the way to establish and cement a strong base of understanding and knowledge of your trig. In this revision series of videos, we take a look at each of these theory points bulleted here, as well as their application. This application often requires a combination of these theory points and can lead to trig feeling rather complex. And so because of this, we suggest you really get into understanding why each aspect is necessary to be considered, as this definitely helps it all come together and make sense as a whole. So, starting with the definitions of each ratio, it is helpful to know these definitions confidently using both x, y, and r and OA and H so that your knowledge is flexible for whatever context your triangle appears. For example, knowing the definitions using OA and H enable you to do trig comfortably no matter where or how the triangle lies. And using the x, y, and r definitions, for example, help you to understand why each of the ratios are positive and negative in the respective quads. Let's consider for a moment here the specifics of how the signs work for each ratio with reference to x, y, and r. So sine first, which is y over r, is positive therefore where y is positive and negative where y is negative. If we look at cos, which is x over r, it is positive where x is positive and negative where x is negative. And then for tan, which is y over x, its sign therefore depends on the signs of both x and y. In other words, tan is positive where x and y have the same sign and negative where their signs differ. It is important and helpful to remember that trig is all about ratios within a triangle. In other words, it is about the relationships between its sides and its angles. And it is because trig is based on the concept of ratios that we can use reduction to simplify. There are two rules we use when reducing ratios of angles to ratios of acute angles. The one is the 180-360 degree rule and the other is the 90 degree rule. The 180-360 degree rule, also known as quad angles, is used when angles are greater than 90 degrees. There are two important aspects to consider when working with this rule. The first is to consider which quad the angle lies in so that you can know whether the ratio is positive or negative. And the second is to identify the acute angle formed with the x-axis. You'll see in each of these cases that this angle has been notated as theta. By seeing which quad an angle lies in helps us identify this acute angle, which we often call the reference angle. And because of the whole concept of similar triangles, the trig ratios for the big angle, in whichever quad it may lie, will be the same as the ratios of this acute angle theta. Just to confirm this concept, consider the triangle formed with the x-axis in each case. These triangles are similar to the triangle we can form in the first quad using this acute angle. And therefore, all these triangles will have the same relationships between their sides and their angles. Let's go on now to see what applying this rule looks like. We'll start here by looking at sine. Remember, sine is positive above the x-axis where y is positive, so positive in the first and second quad, and negative below the x-axis where y is negative, so negative in the third and fourth quad. The sine of a second quad angle will therefore reduce to a positive ratio of the acute angle made with the x-axis, also known as the reference angle. The sine of a third and fourth quad angle will each therefore reduce to a negative ratio of this reference angle. Sometimes we reduce with unknowns in the angle, in this case theta was used, and other times our angle has a numerical value. Let's have a look now at the necessary steps for this scenario. You will soon start getting into the rhythm of always considering two aspects each time you reduce. The one aspect is which quad the angle lies in, so that you can establish the sign of the ratio when reducing. And the other is calculating the value of the reference angle, which is the acute angle being formed between the angle arm and the x-axis. You will see we've done some of the thinking here for you already, but pause for a moment to give completing these three numerical examples a try before moving on to check your work. So how did you do with these numerical examples? Remember to double check in each case both the acute angle and the sine. Getting into a good habit of this double thought process each time you reduce a trig ratio is an important discipline and will largely reduce what we too easily cast off as careless mistakes. On to cos now. What is true for cos in each of these cases? Remember, cos is positive to the right of the y-axis where x is positive and negative to the left where x is negative. Pause the video for a moment to give these a think before moving on. How did these three reductions of cos go? So theta in each case is the acute angle, and to confirm, cos is negative to the left of the y-axis, therefore cos is negative in the second and third quads, and cos is positive in the fourth quad, which is to the right of the y-axis. Now let's have a look at some numerical examples, this time with cos, remembering the necessary twofold thought process each time. Pause the video here to give yourself time to do these. And how did you do? Hopefully you used your brain and not your calculator. Just an encouragement to keep your brain fit by doing mental arithmetic. This can make such a difference to your confidence. The more you do it, the easier it gets, and the more it builds your trust in your own brain. If you are totally in the habit of using a calculator, a suggestion to shift this habit is to try a calculation in your head first and then check it on the calculator. I have no doubt you will surprise yourself. And now to complete the picture, let's do the same process for tan. Remember where tan is positive and where tan is negative. Pause the video for a moment now to jot down the reduction of these three tan ratios. So, to confirm, tan is positive in the third quad, where x and y are both negative, and tan is negative in the second and fourth quad, where x and y are opposite in sign. Let's try these numerical examples for tan now, remembering the twofold thinking process for each one. Pause the video to give yourself enough time to do these. Taking a look at the process of reduction one step at a time, here are the acute angles in each case. And here are the sines and the full answers. Did you get these all correct? We haven't spoken much about the first quad up until now, so just to make sure at this point that you've noticed that all the ratios are positive in the first quad, where both x and y are positive. Hopefully you're starting to get nice and comfortable with the thought process required for reducing across all ratios using quad angles, and that hopefully this is all starting to make sense to you from a deeper place of understanding, rather than just learnt rhymes or facts.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.